Hey, how's it going? I'm just going to describe my senior project in this video and then the progress that I just made in the lab. So, there are 5 of us. We are trying to automate an electric golf cart. This golf cart was a professor's that's been worked on over the years, and she offered to let us work on it. So the steering's been already implemented. Um, the software side is done by 3 other members, and I'm in charge. I'm the power engineer, so I'm just providing power to all the hardware components, which includes the microcontrollers. I think we're using a radar sensor and a camera, and then anything else that comes up. I was originally going to use these batteries, like take the voltage across one of them, step it down to supply power to the hardware, but there wasn't enough left over. I think this cart can only run for like 2 hours or something on a full load, and we need those because we want this cart to run all day, because our project is supposed to be able to pick up and drop off students for their classes, and classes last around 8 to 10 hours. So we want this cart to be able to last a full day before charging. So I got a battery. We had this in the supply room. This guy Mark Foreman let me use it. Yeah, it's 55 amp hours, 12 volts, and I need something that's about 50 amp hours or 45 amp hours, because all of the hardware that I'm supplying power to, it's right here. They all require 5 volts, which is like super convenient, turns out. And this is how much they need: 2.5 amps for this board. A Jetson needs 3 amps, and then 3 microcontrollers require 150 milliamps. The camera is going to be supplied. The power is going to come from the Jetson, and this is going to supply power to the radar. So as of right now, I'm just designing my power system to supply power to these devices. So total, it's 5.95 amps times 7 or 8 hours. It's about 45, 50 amp hours. So this battery is perfect for what I needed. And this is the circuit that I designed. So this is the battery, and then it's in parallel with the 2 buck converters, which are also in stock. So I didn't have to buy anything, which is super awesome. And the 2 buck converters are going to step it down from 12 to 5 volts. And then their max current output for these buck converters is 3 amps, which is why I needed 2 of them. I wanted to just use one of them, but yeah, I need at least 5.95 or 6 amps output. So this is going to be the radar on board, the three microcontrollers, and then this is going to be the Jetson, which requires 3 amps. So it is putting the maximum amount of full strain on the buck converter. It needs 3 amps, and then it's gonna have to supply 3 amps, which is the max. But yeah, it should be okay, I think. So the progress I just made, I hooked up battery to a breadboard, following my circuit design. Yeah, the buck converters are in parallel, and then yeah, I just adjusted these 2 things to get output 5 volts. As you can see that, oh, what just happened? What did it do? Oh, it came out done. Sorry. Yeah, so you can see at that resistor, it's 5 volts, and then it should be the same for this one. Yeah, 5 volts. So now I'm just going to get the proper resistor values. I think right now I'm using just 1K just for this its first setup. So I'm gonna get the correct resistor values and then measure the current across them to see that works well. And yeah, that's my current progress. I'm also working on the steering for my last part. Um, that was done by a previous student, and he did a good job, but he didn't leave the best documentation. Maybe I'm just stupid. I can't follow what he did, and I can't replicate his results. It's not like turning properly. But yeah, that's after I finish the power stuff. So yeah.